today we are going to learn theories, isostasy, continental drift and plate tectonics. So, before learning into the theories, we should know about the distribution of the continents and the oceans on the earth's surface. So, I will give the brief introduction of these two things. Continents cover 29% of the earth's surface, whereas oceans cover remaining portion, that is 71% area of the earth's surface. The positions of the continents and oceans on the map which is existing today have not always been the same. It is now widely believed that seas and continents will not be able to maintain their current positions in the future. Then the question arises that what were their previous positions? Why do the plates alter their paths and how do they do it? If it is true, that is the position of the continents and the oceans have changed and are changing till today and will change in future also, then it is wonder how do we come to know this. So, answer to these all questions, if you learn these theories, you will get the answer for the above question. So, first and foremost theory is that isostasy. The isostasy means, it is a word which is derived from the two words Greeks iso and states, meaning thereby equipoise with or equivalent to, that is nothing but isostasy is nothing but the mechanical stability between the upper earth and the lower basin. So, this is the word which is coined by the geophysicist Hutton in 1829. So, main theory of the isostasy mainly based on the buoyancy and the gravity. So, in 1889, American geologist C. Dutton formally introduced the term, making isostasy a fundamental concept in earth sciences. So, it signifies the state where the earth crust, that is, floats at an elevation determined by its thickness and the density. If you are continuing this, major earth landforms like mountains made up of lighter seal with a density of 2.7 grams cubic centimeter and the plains which are composed of denser sima with a density of 3.0 grams per cubic centimeter exhibit a theoretical balance. That means this balance is established as if these large portions of earth lithospheres are floating on the denser, viscous and partially molten asthenosphere, which is known as the upper mantle section with weak plastic rock. So, isostasy is a key geological concept, dictates regional elevations of the continents and the ocean floors based on the densities of their underlying rock, showcasing the dynamic equilibrium in earth crust. So, in other words, we can say that the Himalayas which are floating in the denser magma with their portion sunk in the magma in the same way, as we know that boat floats in water with its maximum part sunk in the water, that is principal to flotation, that ratio is 1:9. So, in the theory of isostasy, mass above sea level, if you think that this is the sea level, the mass above sea level is supported by the below sea level at certain depth. The total weight per unit area is equal all around the earth. So, which is known as the depth of compensation. So, in regarding isostasy, there are n number of theories, like 8 theories have come into the picture, but out of these 8 theories, today we are going to learn or we are going to concentrate on the only 2 theories, that is theory of Sir George Ayer theory and the Arcadian Pratt theory. So, let us go into the detail. So, isostatic effect was first documented by the observational evidence in the late 1850s by Sir G. Everest in connection with his leadership of the Great Survey of India. In this work, isostatic compensation could explain while the large topographic masses of the Himalaya. So, the observational results were theoretically explained by Airy as well as the Pratt. So, let us go into the Pratt concept. What was his concept? Let us look into that. So, central theme of his concept, that is Pratt's concept, is that uniform depth with varying density. To prove this, he has done a experiment called as, he has taken that line of compensation. So, to prove this, he has filled a glass with mercury and put some of the varieties of equal weight rods in that vertical position. So, even though the weight of these rods is equal, the density is different from each other. So, all these rods are submerged in a mercury at a uniform depth as shown in the figure. You can look at that figure, isn't it? So, all these rods are submerged in a mercury at uniform depth, and all these rods have equal surface area, but they have difference in the height above the surface of the mercury. So, that's BRAOU's concept of inverse relationship between height of the different columns as well as the respective densities can be expressed in the following manner, that if the bigger the column, lesser the density, smaller the column, greater the density. So, according to BRAOU, different relief features are standing only because of the fact that their respective mass is equal along the line of compensation because of their different densities. So, according to BRAOU, a line of compensation above which there is a variation in density of different columns of land, but there is no variation in the density below this level. So, that was the BRAOU concept. Now, we are going to learn that the Airy concept, how it is differs from the BRAOU concept. So, according to Airy, the inner part of the mountain is compensated by the lighter material the below. According to Archimedes' principle, he believes that a material floating on the water means that a greater part of the material is submerged into the water. So, by applying this concept, he tries to explain that the crust of relatively lighter material is floating in the subtraction of the denser material. In other words, he says that Sial is floating over Sima. The Sial, which is having lighter material, is floating over the Sima, which is having the denser material. So, Airy postulated that if the land column above the surface is larger, its greater part would be the submerged below the surface, and if the land column is lower, the smaller part would be submerged below the surface. In other words, mountains, plateaus, plains have varying depths depending on their length on the ground. The conclusion that every landform above the surface of the earth must have a root below in accordance with its height. So, the density does not change with depth, that is uniform density with varying thickness. So, the difference between the Airy concept and the BRAOU concept is that BRAOU may not explicitly endorse the law of flotation as presented by the Sir George Airy, but there is an indirect connection observed through BRAOU concept known as the law of compensation. So, similarly, though BRAOU does not directly support the concept of root formation, but a careful observation suggests that the idea of isostasy indirectly indicates the presence of roots. The key distinction between Airy's and the BRAOU's perspective lies in the fundamental principle that BRAOU posits the idea of equal mass along the line of compensation, expressing it as uniform density with varying thickness. On the other hand, Airy's new emphasizes that uniform depth with varying density. This difference in approach highlights the contrasting ways in which these geophysics conceptualize the distribution of mass and density beneath the Earth's surface. That's how we have come to know that the mechanical or stability between the continents and the oceans which are placed on the Earth's surface. Now we are moving to continental drift theory. Prior to this, we have learned about the stability between the continents and the oceans on the Earth's surface. Now we are learning continental drift. The name itself has the meaning that drift is the movement of the continents. In the first slide itself, we have posed a few questions. So, answer to those questions, this continental drift theory is also one of the answer for that. So, if you go to the introduction part of the continental drift theory, this theory was initially proposed by the Abraham Ortelius in 1596, and the other scientists named Antonio Sneijder, Pellegrin, many of them have worked on this theory, but and another scientist J.D. Dana proposed a permanent theory based on the study of the shapes and size of the continents and all. Just he told that the features like continents and islands, oceans are immovable thing, that is they are constant since since the date of their formation, but this theory was strongly criticized by Taylor in 1908. According to him, there are two land masses named Laurasia and the Gondwana in the Cretaceous period near the north and south poles respectively. He assumed that the continents were made up of seal which was absent in the ocean crust. So, he also said that the continents were moving towards the equator and the main driving force was the tidal force. So, according to Taylor, continents were displaced in two ways. What are those two ways? One is equatorward movement and the second one is westward movement. So, he said that driving force that was responsible for these type of movements was the tidal force of the moon. Thus, he showed a new way to solve the problem of knowing the origin of the continents and the ocean basin. So, after all this observation, many of them have done work to show the continental drift theory, but after this all observation, the new scientist has come into the picture. Alfred Wegener propounded his theory on continental drift theory in 1912 in his French book, but this theory has come into limelight only after 1922, after it was translated into the English in 1924. So, for any theory, if it has to be proven, means there has to be some sort of evidences should be there, which are going to learn now. Though the climatic change has occurred on the globe can be explained in two ways according to him. What was the two ways? First one is that, so if we consider the climatic zones remain stationary, then the land masses might have been displaced and drifted. The first proposal. The second proposal of him is that, in contrast to the above statement, if the continents remained stationary at the same place since the origin of the earth, then the climatic zones might have shifted from one region to another region. So, about two statements, the Wegener chooses the first statement and rejected the second statement. What was his statement? He has considered that the climatic zones remain stationary, then the land masses might have been displaced and drifted. So, thus he rejected, by proposing the first idea, he rejected the idea of the permanency of the continents and oceans. Now, what is the origin of the theory? Let us see that. Around 300 million years ago, in the Carboniferous period, a single massive continent called as the Pangaea existed, which is surrounded by the mega ocean known as the Panthalassa. So, during the Jurassic period, approximately 200 million years ago, continents experience horizontal displacements moving northward as well as the westward. So, Pangaea was separated by the Tethys, narrow and shallow elongated water bodies on the continent, and Laurasia, comprising North America, Europe and the Asia, formed the northern part of the Pangaea, while Gondwana, including South America, Africa, Madagascar, Peninsular India, Australia and the Antarctica, represents the southern part. So, Pangaea was situated near the current South Pole in the southern hemisphere. Over time, in due course of time, Laurasia and the Gondwana land fragment into the smaller continents as we see today. So, this you can see that. So, before that, that means we were talking about 300 million years ago, the landmass was like that. Slowly the Tethys entered into the these landmass and it has become Laurasia landmass and the Gondwana landmass, and again that Laurasia landmass has been divided into these many continents, and the Gondwana land mass has been divided into now this continent. So, this is the now this present picture has come into the picture. So, what are the evidence? To prove every theory, we should know the evidences. We are learning here evidences like geological evidences. So, Wegener noted a geographical resemblance in the continents along the Atlantic coast, that is, which is famously known as the jigsaw fit. What is the jigsaw fit? That is the coastline of the continent. Certain continents seem to be fit together like a piece of puzzle. We can see that here, you can see that this is the South American continent and this is the African continent. If we merge these together, this horn will fit into this over here. So, this is known as a jigsaw fit, isn't it? Next one is that Bullard in 1964 pointed out that similarity in the Gulf coast of Africa and the Brazilian shoal, particularly in areas with gold deposits. That means in the both the coastal areas we have found the gold deposits. So, geological evidence indicates similarity between the St. Catherine Plateau in South America as well as in Karoo Plateau in the Africa. So, the coastal mountain system of Caledonian and Hercynian on the western and the eastern sides of the Atlantic, along with the Appalachian Mountains in North America, align with corresponding features on the British Isles and the Scandinavia. If we go for the glacial evidence, then we can see that existence of the large coal deposits in temperate regions of the Europe and North America is another evidence of the continental drift. Wegener questioned that why coal deposits were found on the cold temperate regions and why glacial deposits were found near the equator, isn't it, which is true statement. The glacial deposits in the southern hemisphere indicates that it was covered with ice sheets around 200 to 300 million years ago. The glacial till deposits have the same stratigraphic position but found in South Africa and South America as well as in India and the Australia. So, erratic of glacial origin, striated and the grooved bedrocks are also found in the different regions, indicating locations of continents near to Antarctica where it is presently located. Now, you can see that the biological evidences also. The fossil remains of both flora and the fauna support the continental drift theory as a first of similar structure and composition can be found on separate continents. That is, Wegener cited many such organisms and the fossils on different land masses. For example, you can see the same fossil fuels in the South America coast as well as the African coast and the mid-term of India as well as the Australia part of these all things. We can see that the similar fossil remains of both flora as well as the fauna. So, based on the study on the fossil remains in the different continents, one such example is of the remains of the Glaspotteris fern, which was found in the Brazilian coast as well as the it was also found in the African coast and as well found in the India as well and the Australia. So, this type of fossil remains is found in South American coast, African coast, Indian coast, India as well as the Australia. So, these will show the biological, these will corroborate the theory of the continental drift, isn't it? So, next is social evidence. Till today, geological evidence we have learned, glacial evidence and the biological evidence. Next is social evidence, that is Swiss geophysicists believe that Gonds tribe is closely associated with the word like Gondwana. Now, next evidence is geodetic evidence. The westward drift of Greenland at the rate of 20 centimeters per year is indicated by the geodetic evidence. For example, the Greenland island is traveling towards North America. This phenomenon is confirmed by the geodetic survey which was conducted by the American scientists in the year 1823, 1870, 1917 and 1970. In the year 1892, the England scientists proved that Green Island is moving away from the England. So, this is the geodetic evidence. Then we go for the geophysical evidence that according to geologists, the north and south poles are not constant. They have been changing their position since many years. Due to this, the magnetic properties of the earth also keep changing accordingly. And this theory states that north and south poles have changed their position. So, till today we have learned the geological evidences, glacial evidences, biological evidences and the geodetic evidences. These all evidences we have learned which have been corroborated the existence of the continental drift theory. But in spite of all this theory, we have also have the criticism. Let us know the criticism of that. So, the forces that are leading to the drift in the continent cannot be adjusted, and the second criticism of the continental theory is that the oceanic crust has less density than the continental crust, or it is not in such a physical condition to allow the slide of the continental crust. His explanation of mountain formation on western edge of the continents was unscientific. That means the continental drift theory has not given much explanation regarding the existence of the mountain formation on the western edge of the continents. So, he failed to provide a cohesive picture of the geological history of the earth, that is, he never ever explained the pre-Carboniferous period, because he started from the Carboniferous period, isn't it? So, he failed to explain the formation of all the young fold mountains of the world. So, in spite of we are having these many evidences, we do have the criticism of the continental drift theory. Based on this criticism of the continental drift theory, another theory named as the plate tectonic theory, which has come into existence. Let us know about this theory. Plate tectonics. The name itself has the meaning. My dear students, try to explore the meaning by the name itself. Plate tectonic. Tectonic is nothing but the moment. Plate is the rigid slab, that is movement of the rigid slab. Plate tectonic theory will give the explanation of the movement of the rigid slab. So, emerging in 1967, the plate tectonic theory an extension of the Wegener's continental drift theory, because continental drift theory has given the basic idea of the movement of the continents and the oceans. So, based on the basic idea, again that plate tectonic theory has been come into the picture. So, based on this that is why we are calling it as plate tectonic is the extension of the Wegener's continental drift theory, challenged by J.D. Dana's permanence theory, because J.D. Dana's permanent theory has told that continents and the oceans are stationary only, wherein continental drift theory is saying that oceans are moving. So, that is the reason why we are telling that plate tectonic theory is opposite to J.D. Dana's theory, and it is an extension of the Wegener's continental drift theory, which was introduced by the Morgan, McKinsey and the Parker. It defines the Earth's lithosphere as rigid plates composed of both continental as well as the oceanic lithosphere. So, let us see the what is the concept of the plate tectonics. So, this is the word which was coined by the Canadian geographer J.T. Wilson in 1965. The theory based on the Euler's geometrical theorem proposed the paving stone hypothesis by McKinsey and the Parker in 1967. It explains the continuous formation and the destruction of the oceanic crust at mid-oceanic ridges and the trenches respectively. The lithosphere consisting of 7 major and the minor plates undergoes tectonic activities primarily at plate margins, including seismic events, volcanicity and the mountain building. Let us see that what are those major plates and the minor plate. You can see now, you can have a picture over here, plates distribution on the earth surface. First is Eurasian plate, which is the continental plate, purely continental, and it encompasses parts of Europe and the Asia. We have the North American plate, we have the South American plate, we have African plate, Indo-Australian plate and the Pacific plate, Antarctica plate. So, these all plates are either they are continental plates or they are combination of both, like continental and the oceanic plate. For example, North American plate is there. It is a combination of continental as well as the oceanic plate. Before that, if you look at the Eurasian plate, this is a purely continental plate. If you look at the Pacific plate, this is purely the completely oceanic plate. So, thus the plates are combination of both continental as well as the oceanic. Then we have a smaller plate like Cocos plate, Nazca plate, Arabian plate, Philippine plate and the Fiji plate and Carolina plate. So, what is the technique behind the plate tectonic? Let us know. So, as we have discussed about this entire plate tectonic theory is based on the 3 movements, that is plate margins movement. Those movements are divergent movement, convergent movement and the parallel movement. So, let us know the movement, though based on these movements are only the entire plate tectonic theory will be explained. Okay. So, as we have learned that these plates have been constantly moving over the floor throughout the history of the earth, these movement it is very important to know this about movement of these three things, isn't it? So first let us know the divergent movement of the plate boundaries. If you go for the divergent movement, divergent means if you consider these are the two plates, so divergent means this plate is moving this side and this plate is moving this side. Two plates are moving opposite direction, then that is to be known as the divergent plate boundaries, where whatever the upwelling magma is there, it will come onto the earth's surface and the sea floor is spreading occurs as the basaltic magma erupts and the separate. So example of this divergent plate boundaries is that the East African Rift Valley, which is formed by the African and Somali plates moving apart, stand out as a significant geological feature on the continent. So these constructive boundaries, why we are saying constructive, because when these two plates are moving opposite direction and whatever the magma inside is there, it is coming erupts and it is whatever basaltic magma is there, it is standing over here. That means it is constructing the sea floor spreading. That is the reason why we are calling the divergent plate boundaries as the constructive boundaries. So you can see that picture, this is the plate 1, this is the plate 2, when they are moving opposite direction, some sort of a landform or anything relief feature is creating. Here when we are looking at this, mid Atlantic ridge is creating by the divergent plate movement, isn't it? So this is a brief about divergent plate margins. Coming to the next movement is convergent plate margins or destructive plate margins. In the convergent plate margin, when we have seen the divergent, both moving opposite direction, in the convergent both the plates are moving towards the direction. That means whenever they are coming towards each other, that is to be called as the convergent movement, and that boundaries are known as the convergent plate margins. If the convergent movement is there, there are three things can happen. That means the convergent movement can take place within either two oceanic plates or two continental plates, or it can take place between one oceanic plate as well as the continental plate. So with the help of convergent movement or due to convergent movement, three things can take place, that is origin of fold mountains and the origin of volcanoes and the origin of ocean trenches. So let us see origin of fold mountains. See, this is the one plate and this is the another continental plate. When they are moving towards each other, whatever the middle portion is there, it will be get folded due to a horizontal pressure. That's how. What is the example of this convergent movement or the formation of the fold mountain is that you can give the very good example of this, that when the Indo-Australian plate moved into the Eurasian plate, that's the Himalayas were formed. That means Indo-Australian plate is one continental plate and the Eurasian plate is another continental plate. When these two plates are moving towards each other, whatever the middle portion is there, it has been folded due to the pressure which is created by these two plates, isn't it? That's how the Himalaya mountains were formed. This is the good example of the origin of the fold down mountain. The next activity is that origin of volcanoes. Whenever volcanic activity is closely linked to plate margins, with the world's most active volcanoes concentrated along these boundaries, that is approximately 80% of volcanoes are found on the destructive plate margins where convergent plate collide. Why we are saying it at a destructive? Because when they collide with each other, there is a part of destruction. That means some sort of relief feature is getting destructed. That is the reason why we are calling it as a destructive plate margins. So in convergent plate collisions leading to subduction zone, the heavier plate bends, allowing the lighter plate to slide over it. Subducted plate melt in the upper mantle, forming magma that erupts explosively on the earth's surface. Notably, volcanic regions associated with convergent plates are the circum-Pacific belt and the mid-continental belt. So that's how the volcanoes like Etna, Vesuvius and Stromboli near the Mediterranean Sea have been formed. The third thing is ocean trenches. This is also similar to formation of the volcanic of origin of the volcano. So third movement, first movement we have learned the divergent movement and the convergent movement, and the third movement is parallel movement or the conservative plate margins. In this movement, two plates slide over one another side by side in a such a way that neither they will collide nor they move away. So thus this type of plate movement neither creates nor destroys any landform, and hence it is called the conservative. And the example of this San Andreas fault is a result of the parallel movement of the Pacific plate as well as the North American plate. So thus we have described about the isostasy, continental drift theory as well as the plate tectonics, and whatever the questions we have posed in first slide, those answers have been cleared or given by the plate tectonic movements. So thus now which is existing today. Thank you.